Our project is a Smart Dash that receives car data from an OBD connector, accelerometer, and GPS chip. The data is parsed and transmitted to the Raspberry Pi using serial. The Pi then outputs the data to the user.
The OBD portion of this Smart Dash uses a serial connection with CAN bus and the OBD2 standard to gather information from the internal sensors in the car. This can range from speed to RPM and even to airflow and trouble codes. The unit also receives power over OBD and is able to power itself along with the GPS module. Software serial communication is then used to send live statistics to the data logger for further processing.
The Raspberry Pi was connected to the data logger using a USB Type A to B connection. The data was transmitted using serial, parsed by the Pi, and displayed to the GUI. The Pi was also powered using an external battery pack. The GUI for the Raspberry Pi was programmed in Python using a tkinter library. The GUI consists of 3 modes: race mode, current stats, and graph mode. Race mode displays the current speed, RPM, gear, and shift timing. The screen will turn green when you should shift and flash red when your car is redlining.
This Arduino gathers acceleration data and GPS coordinates, then sends them to the central data logger Arduino, which sends the values to the Raspberry Pi. The 2 devices connected to the board are an accelerometer, gyroscope, and a GPS. The accelerometer connects to the Arduino through I2C protocol. The GPS connects through serial. The GPS libraries handle fixing with satellites and receiving data. All we have to do is call the library function to return a certain value.
For this project, I was in charge of the data logging. I have a Arduino Mega with a SD shield connected to it. That way any information being passed to me is stored. The first Arduino that's connected to the OBD sensor, it's sending its information to me through serial. And then I have the second Arduino sending information about the GPS and accelerometer to me in the second serial port. After collecting it, I store it onto the SD. After storing it onto the SD, I format it accordingly and pass it on to the Raspberry Pi, which then displays that.